Okay, yeah, so now we're going to introduce one complete example for you to understand how do we formulate and solve a signaling game. In this example, we will consider a firm making and selling a product with hidden reliability. Okay, there is a probability R, which is the probability for the product to be functional, and R will be a number between 0 and 1. So with some probability, the product is going to be to fail. Okay, so consumer will buy this product, and if the product works, the utility will be theta. Theta is the how the consumer may enjoy this product. But if the product fails, the utility will just be 0. And also, the net utility must consider the price the consumer pays to the manufacturer. Okay, so it will be theta minus t if the product works, or minus t if the product just fails. The firm may offer a warranty plan, and in that case, the firm will be responsible for repair a broken product. If that happens, the firm must pay the repairing cost, K, which is greater than 0. Okay, the consumer does not care about K. The K is totally paid by the firm, and in that case, the consumer's utility will jump from 0 to eta. Okay, eta is assumed to be a number that is greater than 0 but smaller than theta. Eta is how the consumer may enjoy a repaired product. We assume eta is lower than theta because even though you get a repaired product, it may not be as good as a new one. And also, when you return the product to the manufacturer and get it back after several days, you get some inconvenience, right? Or you may assume that the difference between eta and theta is the cost for you to mail or to bring the product back to the manufacturer. Anyway, yeah, there is still something you may get after the product is repaired. To make things simple, we will assume that the price is fixed so that we may focus exclusively on the warranty decision. The manufacturer only make one decision, whether to offer the warranty by setting W to be 1 or to set it to be 0 and to offer no warranty. With all these notations, the expected utilities can be determined in the following ways. The firm's expected utility can be expressed as T minus 1 minus R times KW. So the manufacturer definitely gets the payment T, but with probability 1 minus R, the product will fail. And if there is a warranty plan, the manufacturer needs to pay K as to fix the product. The consumer's expected utility is this one. With probability R, the product would be fine and the consumer gets theta. With probability 1 minus R, if there is a warranty, the consumer can get the repaired product and the utility eta. Otherwise, if there is no plan, then this part is just 0. The consumer needs to pay T in any case. So with this in mind, the consumer will buy this product if and only if the expected utility is non-negative. And if the consumer does not buy it, then both of the players will get a 0 utility. With that in mind, the firm is going to choose whether to offer the warranty accordingly. Okay, the product may be either good or bad, reliable or unreliable. Okay, so we assume that R may be either RL or RH, and we assume that RH is higher so that if the product is of a higher reliability, that means it is more likely for the product to be functional. Suppose we have a complete information case, then the decisions can be made easily. This is the case that the manufacturer's type or the reliability is observable by the consumer. So in that case, the firm's expected utility simply we change R to be RI. RI can be either L or H. And the consumer can observe the type. So the consumer make decisions according to whether R is high or low. And this decision can be made just as when there is only one type of consumers. One type of manufacturers. If in a more realistic situation, there is incomplete information or there is information asymmetry, then one thing they may do is to make decisions according to the expected reliability. One important thing here is that from the consumer's perspective, the reliability R is random. Okay, it's a random variable. So the consumer must have some kind of prior belief on the reliability of the product. Okay, so let's assume beta is the probability for R to be RL, and so that means 1 minus beta is the probability that R is RH. With that in mind, we may define the expected reliability as R bar, and that can be used for the retailer, for the consumer to make decisions. The firm can observe the type, so this is something for the firm's expected utility. The consumers cannot, and thus the consumer's expected utility is calculated like this. This is the case if the consumer is extremely naive, and that means the consumer does not take the manufacturer's decision into consideration. However, if the consumer is rational enough, then the consumer should notice the following thing: is that the unreliable firm will tend to offer no warranty, right? Because for an unreliable firm, RL is small, and that means it is more likely for the unreliable firm to pay this repairing cost. And if K is high enough, or if R is small enough, then this cost will be too high, and the unreliable firm will prefer not to offer a warranty. And in that case, the consumer will be able to find the type of the manufacturer by observing the warranty policy. Okay, so this is the basis of signaling. And the basis is that different type of manufacturers have different preferences, and it may be translated into different actions. But here, we're going to work on this numerical example. So we will assume these particular parameters. RL is 0.2, RH is 0.8. Well, when the product is good, the consumer gets 20. Otherwise, the consumer gets 5 if the product is repaired. The price is 11 and the cost is 15. Collecting those numbers, we can get these payoff matrices. Okay, and just as an example, suppose the product is reliable. If the consumer does not buy this product, everyone gets 0. If the consumer buys the product, then as an example, if the manufacturer offers the warranty plan, in that case, the manufacturer gets 8. Why? First, the manufacturer gets the payment, 11. And then, because the product is reliable, the probability for it to fail is 0.2. This is the probability for the manufacturer to pay the repairman cost. Cost is 15. So 11 minus 3 is 8. Well, the number here, the manufacturer's expected utility. Or for the consumer may get with probability 0.8 the utility theta, which is 20. This should also be added by another probability to get the repaired product, 5. And then the consumer needs to pay 11. Okay, well, certainly we are assuming that there is a warranty plan, and that's why we have this term. Anyway, 16 plus 1 minus 11, we get 6. Okay, now this is how we get this payoff matrix. And similarly, if the product is unreliable, these numbers will be adjusted accordingly. Yeah, and here, because this is -1, we can see that it is indeed unprofitable for the manufacturer here to offer the warranty plan because it is too costly for the manufacturer to pay this repairman cost. But the issue here is that the consumer does not know which metrics the consumer is facing. So the challenge for the reliable firm is to convince the consumer that it is the first one, because in that case the consumer will be more willing to buy this product, right? So here, the warranty will serve for two functions. It may first attract consumers by providing protections or insurance, and second, to signal the reliability. Okay, we will take everything into the following game tree because this is a game with sequential decisions, right? So it's natural to represent everything by a game tree. But because here we have a we have a game with incomplete information. So in the game tree there are something new to us. Yeah, we're going to see that. Anyway, those things that are inside a box are players. We have a special player nature, which is not really a player, but we use this and we use something you may treat it as a randomized decision to represent the fact that RH or RL is random and it will be realized just like nature, the player chooses RH or RL randomly. Certainly the nature does not care about the payoff, so in effect this just means this value will be realized randomly with probability 1/2 and 1/2. With 1/2 here, we are assuming that the consumer has no way to justify or to make any conjecture. So the best the consumer can do is to flip a coin and to give 1/2 1/2 as the prior belief. Anyway, here, at least two notes, the decision maker is the firm, and the firm observes the realization of reliability, and then the firm makes the warranty decision whether W should be 1 or 0. And then it's the consumer's turn. The consumer observes, for example, a warranty plan, but the consumer does not know which node he is at. Okay? The consumer knows is either this one or that one because the consumer sees the warranty offer, but the consumer is not sure whether it is this node or this node. And then the consumer makes a decision, buy or no, and then they get utilities. The first one is the firm's utility, and the second one is the consumer's utility. If the consumer observes no warranty plan, he also needs to make two decisions and earn warranties accordingly. So we use this dashed line to represent the fact that there are incomplete information, and when the consumer is locating at a node, he cannot tell whether he cannot tell which node connected by the dashed line he is it. Okay, so this is the case. We use this dashed line to represent for incomplete information. So the last thing we need to do to describe this game is to tell you what's the concept of equilibrium here. We will care about only pure strategy equilibria. So in this signaling game, what will be the elements of an equilibrium? We know we have decisions. There are, in some sense, two firms, or you can say that the firm needs to make a plan. If my type is H, what should be my decision? Or if I am unreliable, what should be my decision? Okay, warranty decisions. The consumer also need to build his strategy. If I see W is 1, a warranty, what should I do? Or if there is no warranty, what should I do? Moreover, there are beliefs in this incomplete information game. I am going to use P and Q to denote the conditional probability for you to believe that the product is good when you observe a warranty or no warranty. Okay? P is the case that the consumer sees a warranty plan and then the consumer updates the belief about whether the product is reliable. And Q is the case when no warranty is observed. So we have decisions, we have beliefs. An equilibrium will be a strategy belief profile. It's a collection of the manufacturer's decisions, the consumer's decisions, and updated beliefs. This collection is an equilibrium if the following three things are true. First, no firm wants to deviate according to the consumer's posterior belief. And second, the consumer does not want to deviate according to his posterior belief. And finally, the beliefs are not given. The beliefs are determined or affected by the firm's action. And the rule is the base rule. So we can see that the firm's action is based on the belief, but the firm's action will also determine the belief. So it would be just complicated to solve a game like this. Okay, so because of this kind of if you like it, you may call it a recursive relationship. It's hard to search for an equilibrium. It is easier or it can be done if we want to just check whether a given profile is an equilibrium. So we're going to we're going to check all possibilities. And we typically start from the principal's action. So we're going to ask whether 1-1 is a possible part, whether 1-1 is a part of a possible equilibrium. Is it possible for two firms to both offer warranties? Or we may ask, is it possible for none of them to offer warranty? Is it possible for only one of them to offer warranty? And if it's possible, which one? Okay? Eventually, that's the question we want to ask, whether it is possible for the high guy to signal its reliability. And we're going to do that in the next video. Thank you.